Hello everyone. Today we are going to learn about joins in SQL. I am Pushkar and I am going to be presenting this to you. In today's session, we are going to learn about following points. First, we will start with the Venn diagram. Here, we are going to understand the concept of the Venn diagram and interpret them. Next, we are going to see different types of join in the SQL. First, we will start with the inner join, followed by the left join, then right join, then outer join, and at last cross join. So there are five types of join in SQL primarily, and we are going to understand these joins with the Venn diagram and an example. So to begin with, let's start with the Venn diagram. So Venn diagram is a concept in the set theory. It is used to define relationships between two sets. Okay, so to give you brief about what sets are, a set is a collection of unique items. Uh, so there will be no repetitive or duplicate items in a set. Here we have two sets, set A and set B. Let's assume set A contains even number between 1 and 50, while set B contains multiples of 5 between 1 and 50. So set A will have values like 2, 4, 6, 8, 10, 12, 14, and so on up to 50, while set B will have values like 5, 10, 15, 20, 25, and so on up to 50. So here the first operation is a union operation. So union of set A and set B will result in a set that will have values either from set A or set B. So referring to our example, union of set A and set B will have values or numbers that are even as well as multiple of 5. So such numbers will be 2, 4, 5, which is a part of set B as it is multiple of 5. Then 6, 8, 10, 12, 14, 15, 16, 18, and so on. So that is the union operation. Next is intersection operation. So intersection of two sets will result in a set that will have common values from both the sets. Okay. Here, the yellow part you see is the intersection of two sets. So referring to our example, intersection of set A and set B will result in numbers or values that are even as well as multiple of 5. So such numbers are 10, 20, 30, 40, 50. So that's the intersection of two sets. Third operation is a minus operation. So set A minus set B will result in a set that will have purely values of A. So all the common values that are between set A and set B will be dropped. So set A minus set B will result in values or numbers that are 2, 4, 6, 8, 10 will be dropped as it is a part of set B and a multiple of 5. Then next number would be 12, 14, 16, 18, 22, and so on. Okay. The last operation is just vice versa of the above operation. So set B minus set A will result in a set that will have pure values of set B. All the common values between set A and set B will be dropped. Okay. So set B minus set A will are the numbers that are multiple of 5 and not even. So such numbers are 5, 15, 25, 35, 45. Okay. So this is the theory of the Venn diagram. Here we learned that a set will have unique numbers or unique elements, and Venn diagram will help us to define the relationship between two sets. Moving forward, we are going to use this logic to understand the joint SQL concepts. Okay. To help you understand much better about the joins in the SQL, we are going to refer following example. Okay. Assume you work for a company and this company maintains an employee database. This database has two tables. First table is the employee table. This table contains the demographics of the employees. So here you can see employee table has columns like employee ID, employee name, and birth date. Okay. Second table is the projects table. Here the project table contains the ongoing or live projects in your company. Okay. So the project table has information like project ID, project name, and employee ID. Here our goal is to bring data from the project table to the employee table. So that's our goal. We are going to achieve this goal with the help of joins. And in the following slides, we will see how how we can bring data from one table to another table with the help of joins, and also see how one join differs from the other join. To begin with, here is our first join, that is inner join. Here we have drawn two set A and set B, referred to our Venn diagram example. Okay. Set A contains employee IDs from the employee table, while set B contains employee ID from the project table. Okay. Going back to the example, here you can see employee table has a column called as employee ID, and this has values like 1 to 3, 1 to 4, and 1 to 5. So we have assigned set A to this. So set A will have employee IDs 1 to 3, 1 to 4, and 1 to 5. Whereas set B is the employee ID from the project table. This is the employee ID column available in the project table. So set B will have values 1 to 3 and 1 to 4. To join these two tables, that is employee table and project table, we are going to use employee ID column, which is common in both tables. Okay. So in order to do inner join between employee tables and project table, we will be using employee ID column. So now the resultant of these two tables join will result in a data set that will contain employee IDs that are common between these two tables. So here in our example, we can see if we have uh, employee ID 123 and 124 common between employee table and the project table. So all the information for employee ID 123 and 124 will be available in the data set or the resultant table, but information or the details of employee ID 125 will be dropped as it is not a part of the project table. So that's the inner join. Okay. The output here you can see the highlighted is the output table result or the employee IDs that are that will come as a resultant of the inner join. Okay. Next type of join is the left join. Here the basic theory remains the same. That is, set A contains employee IDs from the employee table and set B contains employee ID from the project table. So now the difference comes in the column that are again joined. Okay. So in left joint, the resultant table will contain all the employee IDs from the employee table, irrespective of if it is available in the pro- project table or not. So it doesn't matter if some employee IDs are not there in the project table. So going back to the example, here all the employee IDs from the available in the employee table, that is 1 to 3, 1 to 4, and 1 to 5 information will be available in the resulting table, whereas you can see 1 to 5 information is not in the project table and that has not affected the result. Okay. So that is the theory of or the concept of the left join. Next, moving forward, we have the third type of join, which is right join. Here again, the basic theory remains the same, that set A contains employee ID from the employee table, whereas set B contains employee ID from the project table. Now the difference here comes in the resultant or the output table. Here in the right join, all the information or the IDs of project table will be there irrespective of if it is available in the employee table or not. So going back to our example, in the project table, we have two employee IDs, 1 to 3 and 1 to 4. So all the data of these two employee IDs will be displayed, and employee ID 1 to 5 is not there. So no information of 1 to 5 will be there. Okay. Because this time project table is the deriving table. Okay. So this is the right join. Now our fourth type of join is the outer join. So here again, the basic theory remains the same, that set A contains employee ID from the employee table, whereas set B contains employee ID from the project table. Now the difference here is that in outer join works as a union of two sets or two tables. Okay. It doesn't matter if there is employee ID available in the employee table or not, or employee ID is missing from the project table or not. All the information or all the IDs that are available in the employee table and the project table will come in the output. Okay. So here you can see output will contain employee IDs from both these tables. Moving forward, we will see queries that you need to run in the MySQL or any SQL platform to get the required results or join two tables. Here we are going. to start with the left join. On the top left corner, you can see the query for the left join. Here, the query states as select followed by list, which will be list of columns that you want to display from table A. In our case, table A is the employee table. So here we have to write the our table name, which is employee table. A is an alias given to the employee table. So this alias, we can allocate this alias wherever this table name is called in order to avoid like multiple times calling the big table name. Okay. The keyword that is used to perform the left join is written over here, that is left join. And this keyword joins employee table with the project table. Okay, table here, table B is the project table. B is the alias given to it, and we have to write the joining condition, like on which column we are performing the join. So on keyword is to be used in order to mention the column name. A is the alias, that is A dot value, which would be employee table dot employee ID, and we are matching it with the employee ID from the project table. Okay, so this query reads as follows: select list of columns from employee table, left join it with project table on employee ID column from the employee table, and map it with the employee ID from the project table. So this is the query to write the left join. Okay. On the right hand side, you can see query for the right join. The query is as it is, only the keyword changing. Here is the type of join you want to perform. Here we can see the join we have mentioned over here is the right join. Okay. So here the outcome of the query will contain IDs from the project table. Moving forward, our on the bottom left corner, you will see query for the inner join. So the remainder of the query remains as it is. The only keyword changing is the type of join you want to perform. Here we have mentioned that we want to do inner join. So inner join keyword is there. So I'll read this query for you. Select list of columns from employee table, alias is A. Inner join, perform inner join with project table, alias given is B, on A dot employee ID equal to B dot employee ID. Okay. So this is the query for inner join. Next query on the bottom right hand side, you will see query for full outer join. Here you again the query is as it is. The only keyword changing is the type of join you want to do. That is, here we want to perform full outer join. So we are writing full outer join over here to join these two tables. Okay, so these are the queries which we can write in the MySQL or any database to get the appropriate results. Moving forward, we will see a fifth type of join, that is cross join. So this join is different from the previous four because this join does not have any control over the joining columns. Okay. In previous queries, we have seen we were joining on two tables based on employee ID column from employee table and the project table. In cross join, there is no control over the columns. It is a Cartesian product of two tables. Okay. To help you more understand about it, let's see the two sets that are displayed. Set one contains values A, B, C, whereas set 2 contains values X and Y. So cross join of these two sets will have values or will result in values or will result in mapping such that each value from set 1 will be mapped with each value of set 2. That is, A from set 1 will be mapped with X and Y of set 2. B will be mapped with X and Y of set 2. C from set 1 will be mapped with X and Y of set 2. So number of records would be set number of elements in set 1 into number of elements into set 2. So here you can see the cross join of these two set will result in a set 3 which has values ax, ay, bx, by, cx, cy. To help you more understand about this join, let's see the following table example. Here we have two tables. First table is the medicine table and second table is the customer table. Okay. Medicine table has column medicine ID and medicine name, whereas customer table has column customer ID and quantity. Here we are performing a cross join. So here each medicine ID will be mapped with each customer. Okay. So here you can see the resultant of the cross join. The resultant table has below medicine IDs, starting with medicine 1, it is mapped with customer 1 and customer 2. Okay, these two records are there for in the customer table C01, C02. So M1 is mapped with C01 and C02. Next medicine ID is M2. It is again mapped with both the customers, that is C01 and C02. Similarly for medicine 3, it is mapped with both customers C01 and C02. So it is just a Cartesian product of two data sets. Here is the query that you will run in order to get the cross join. So the query reads as follows: select star from medicine is the first table name. Cross join is the keyword that you will use in order to cross join these two tables. The second table name is the customer. As there is no control over the columns that we are joining, so no on condition or the joining condition is there in the query. Yep, that's all from the join section. Thank you.